Hello and welcome. I'm Steve Jorson from Northeast Metro Climate Action. We are a volunteer-run community organization with members in White Bear, North Oaks, Vadnais Heights, and Shoreview. Always looking for new members. So if you're interested in what we're doing, just let us know. Our mission is to raise awareness on the climate crisis. We do that through educational events like this. Monthly events we run from September through May. We'll take the summer off and start up again next September. Next month, we will be doing I will be giving the talk, call it Here Comes the Sun. It's about transitioning to a clean energy economy, what's happening already and how successfully that is going on. I'll give you some examples of how well that's going. Our other thing that we do is we work a lot with elected leaders, both local and state level, helping them with drive climate action in their districts and within the state. And with this being an election year, we have a lot of work to do this summer, working with elected officials and tabling at events and so forth. Next month, May, it will be May 18th, right here at White Bear Library, 6:30, same bat time, same bat channel. For those of you online, make sure you keep your microphones on mute. If you have questions, you can put those into the chat. And also people in the audience, Dr. Austin said it's okay for you to ask questions while we're going, or if you have a more general question, we can save those till the end. All right. I'd like to acknowledge that we are on Dakota and Anishinaabe land. We pledge to uphold the rights of self-governance of our sovereign tribes and uphold the rights of Indigenous citizens within our democracy. We are co-hosted tonight by Northwest Metro Climate Action, Vadnais Heights Green Team, Sustainable Stillwater, East Metro Eco Faith Collaborative, Indivisible North Metro Environment Team, St. Croix Valley Indivisible Climate Justice Team, Resilient Roseville, and Vote Climate. Now I'd like to introduce our speaker tonight. Dr. Austin is a professor with the Large Lakes Observatory at the University of Minnesota Duluth. His research focuses on working with large lakes like Lake Superior and focus on seasonality, long-term change, water levels, ice cover, circulation, impact of physics on ecosystems and acoustics. He's been working on collecting data on Lake Superior for 20 years. So with that, I'd like to introduce Dr. Jay Austin.
Well, thanks, Steve, and thanks especially Kate for arranging all of this. It's a pleasure to be down here. My name is Jay Austin. I'm a professor up at UMD, and I split appointments between the Department of Physics and Astronomy and the Large Lakes Observatory, and I will tell you what that is in just a moment. Before I make any comments regarding the subject of the talk, Kate insisted on two things to include. The first was, what the heck is this thing? I'm part of a project right now to deploy a bunch of very large detectors, optical detectors on the bottom of Lake Superior. I'm not going to go into the details of that right now. But the group that's doing this needs a very careful characterization of the optical properties of the water. This instrument is called a hyperspectral ocean color radiometer. And what it does is it measures light levels at a whole bunch of different wavelengths. And what I did after this picture was taken was take this thing and throw it over the side of the boat. And then it sinks straight down. And it has one sensor that's looking up to see what light is coming down, one sensor that's looking down to see what light is coming up. And it measures the intensity of light at different wavelengths as a function of depth. So for instance, this is a piece of data that was collected. These are profiles. So the vertical axis here is depth in the water column. The horizontal axis is light intensity. Don't worry too much about the details. The point here is that red light doesn't penetrate very far. blue and yellow, sort of intermediate, and green light penetrates really far. And so what we need to understand for this project is very specifically and quantitatively how much that penetration, how far that light penetrates. Again, not the subject of this talk, but it is a cool looking instrument and a lot more fun than the profile picture that Kate had originally picked off of the university website. The other thing she asked was about this idea of data as art. And I've not done a whole lot of it. I just thought it's a sort of a fun side thing. The first paper I did when I got to UMD 20 years ago was looking at rates of warming in summer water temperatures. And what we showed in that paper, my colleague Steve Pullman and I, was that water temperatures were increasing faster than regional air temperatures. And we came up with an explanation for that. Turns out we were wrong, and I'm publishing a paper on that right now. But someone called me up and said, I'm a climate change artist, which is a genre I did not realize existed, and said, can I have some of your data from this paper? And she put, I can't remember her name, but she put this together. I have a copy of it on outside my door. I do know Alice's name, Alice Hargrave at Illinois State, did a gallery show called Lake Portraits, of which some of my stuff was included. And then sort of as a fun thing, I spent ages staring at what's called echo sounder data. And anybody who's fished and used an echo sounder to determine the depth of the fish has a sense of what they do. They send out a pulse of sound, they measure the amount of sound that's reflected back. And it tells you about where stuff is in the water column. And I've been staring at this sort of data for years and years on my little laptop screen, and then I realized that I can just pay someone to print out gigantic banners. So in an attempt to sort of bring a little bit of color to the Department of Physics and Astronomy, I had this 15-foot banner printed out. And there's so much really fun detail, all kinds of fun internal waves and solitons. The yellow at the top are air bubbles being entrained by surface waves and reflecting sound. You can actually see individual zooplankton if you zoom in. It's a lot of fun, and it's a reminder that some of this stuff really is quite beautiful. My boss at LLO, Catherine O'Reilly, is very interested. What would you like?
Pull this forward.
Sure. So I can stand here and see the screen.
Yeah.
Recently turned a sitting room into, she found an artist who wanted to display some of their stuff. The artist does very aquatic themed stuff. And so we actually have a little tiny art gallery in our laboratory, which is super fun. Okay, so I mentioned the Large Lakes Observatory. People are familiar with standard academic programs like physics or chemistry or something like that. There are a handful of us at UMD who have an interest in the fundamental underpinnings on how large lakes around the world works. And so we're not the Lake Superior Observatory, we're not the Great Lakes Observatory, we are the Large Lakes Observatory. We have a significant footprint in East Africa. We have people who've worked in Nepal and Indonesia and really around the world. I've had deployments recently in Crater, in Tahoe, Lake Quesnel in Western Canada, because they're interesting things to study, right? And so we don't do restoration and management stuff. We do the stuff that you do before you do that, right? You have to understand the science before you can understand how to carefully manage a system. So we have people from different departments, geology, biology, chemistry, and physics. We work, again, on a very wide range of lakes around the world. And if there's a common thread to the research that we do, it would be climate. I do modern climate. I go out, I make measurements, I look around for data sets that have been underexploited. But we have a group of people at LLO that do use sediment cores to understand past data. And so just before I got to LLO, they extracted a sediment core from the bottom of Lake Tanganyika in Eastern Africa that went back 700,000 years. And so you can learn a lot about East African climate by doing chemistry on these cores. And again, I don't understand the details of all that, but it is an interesting common thread that we have.
Any saltwater or all freshwater?
We go wherever. We actually have people that's still doing some oceanography. And there are saltwater lakes, yes. So absolutely. So my work, my background professionally is my PhD work I did at MIT and Woods Hole Oceanographic Institution, both in Massachusetts. And in fact, most of the faculty at LLO, instead of having a background in lakes, have a background in oceanography. And that's because if you want to work on a lake the size of Lake Superior, you need to bring oceanographic techniques, oceanographic equipment, oceanographic theory to bear in order to understand that you're not going out in a canoe and doing useful work on lakes the size of these. And so I'm primarily an observationalist. In other words, I go out on boats, put stuff in the water, leave it there for long periods of time, and recover it, and then tell stories with the data that we collect from those. Here you can see a bunch of students working on the boat. One of the great joys of this job is working with students who constantly remind me how cool my job is. It's very easy to forget the 50th time you've gone out on the boat and you have all these things you need to do just to see the students being as excited as they are. And so I put climate change at the top, and I should comment that I'm not fundamentally a climate change scientist. I'm climate adjacent. My work would look very similar to what it does if the climate wasn't changing. It just so happens that we have this interesting background signal that we can draw stuff out of. Most of what I've done has been concentrating on that second one, winter and what we call shoulder season conditions. In other words, we know a lot about the Great Lakes during the summer for good reason. It's nice to be out on a boat in the summer and you're not teaching classes. And so you can get out and do that sort of work. I identified fairly early on that understanding winter in these lakes was a big knowledge gap for the Great Lakes academic community. And I basically will leave things throughout the water column of the lake. I'll put them out in the summer and I'll come back the next summer and recover them. And by doing that, we get data around the calendar. And in fact, we have a spot in Western Lake Superior where we've had equipment pretty much continuously since about 2006. And so that's one of the second longest time series anywhere in the Great Lakes for the stuff that I looked. I have a side gig doing acoustics, in other words, listening to the lake and seeing what it sounds like inside. I've done some work with physical biological interaction, in other words, how physics affects biology and ecology of these systems. Convection, that's a little bit in the weeds, and then data mining. And so going out and finding data sets that have been underused. And I like to say that I can put a temperature sensor, and most of what I do is study temperature distribution within lakes. I can put a temperature sensor anywhere in Lake Superior that I want. I've had stuff in very shallow water. I've had stuff in the 400-meter deep hole in the southern basin of Lake Superior, but I can't put a temperature sensor anytime I want. In other words, if I wanted data from 1975, there's nothing I can do about it, right? And so what I need to do is go out and find sources, and I'm going to talk about one of them here, that allow us to sort of hindcast and look into the past. And so if you look at papers that I published, you see winter thermal structure and temperature variability and ice albedo and onset of winter. So very focused on understanding how you transition from one season to the next and understanding how information is passed from one season to the next. Another thing that I worked on a couple years ago, and this is when I realized that there were actual climate scientists. I don't know if people are familiar with the National Climate Assessment. This is a big federal report that comes out every 5 years with hundreds of authors around the country. Basically, a downscaled version of the IPCC. What are the impacts of climate change in the United States? I was about to say this was federally mandated. Unsurprisingly, this went away. But I was fortunate enough to be brought in as the Great Lakes person for the Midwest chapter for the 5th National Climate Assessment. I'd like to say that I was part of the last National Climate Assessment. I'm sad that I was part of the last National Climate Assessment, and maybe that'll get. The ironic thing about this is that all of us are volunteers. It's a relatively low cost. Like they had administrative people that got a salary out of this, but the people who are doing the actual work, the authors on this, none of us got paid a dime for this. UMD operates the research vessel Blue Heron, shown here. This is the largest academic research vessel on the Great Lakes. Can take 11 people out for 10 days at a time. You wouldn't want to be on this boat for 10 days in a row. But I've been all around the Great Lakes. I've actually been down to Lake Erie on the Heron. Um, One of the sort of more practical things that my lab does is operate the meteorological buoys in the western arm of Lake Superior. And so this is just from last week. You can see two of our buoys here and then students. You'll also notice a TV reporter down there. We do our best to make sure that people other than academics know about what it is we do. And so we're very proactive about inviting reporters out for these deployment cruises and stuff like that. And so here you can see us lifting this over the side and then it's deployed. And these buoys measure a whole host of meteorological parameters, wind speed and direction, barometric pressure and air temperature and humidity, but they also measure water temperature at a bunch of different depths below them. This one, I think this one has sensors for water quality, so basic chemical and biological properties, wave height, stuff like that. A computer in my lab every 10 minutes places a call to this buoy and the other ones, uploads the last 10 minutes worth of data, and then disseminates that to various federal agencies. And then places like the National Weather Service, who are very concerned with things like marine safety, take that data to see how well their predictive models are doing. And so if you want to develop and improve models that do things like forecast weather, you also have to be going out and making direct observations. And so I've been able to secure funds for many years to keep these buoys in the water. One last sort of shameless plug here. LLO operates something called Science on Deck. This is an opportunity for us to open up the research vessel to the public. You get tours of the boat and demonstrations, but also one of the scientists from LLO will typically come and give a short presentation like what I'm doing right now. You can see the dates over on the right there, June, July, August, September, Fridays 11 to 3. This is the web. Don't try to type this in right now. If you just Google Science on Deck, you will come to this web page that gives all the deets, as the kids say, about where and when these things are occurring. And so if you're up in Duluth on one of these days, I encourage you to drop by and say hi to the crew. Okay. With all that said, what do we have? Oh my gosh, that was a half hour. So I want to focus on Superior as a case study because it's what I know about. I want to broaden the Great Lakes and Lake globally, and I want to make a case that ice is a climate change indicator and also a real cultural touchstone. People pay attention to it. And sort of a overarching theme of my research has been that even small changes in lake physics can have ecological, commercial, recreational, and cultural significance. Okay, some fast facts. I assume that everybody's been up to Duluth and you go over Thompson Hill and there's this vast expanse of water, and it's worth keeping in mind that the water you see basically is under the letters for Duluth. It's a gargantuan lake, and what you seem to think is a very large lake is only this much of a really, really very large lake. It is the largest lake by surface area in the world. Contains 10% of the world's surface freshwater, 50% of US freshwater. You could empty all of the other Great Lakes into Lake Superior and still have room left over. Very low population density. In fact, it's about 1% of the total Great Lakes region, which is about 60 million. 4 cities alone make up about half of that. And that's good for us, right? Having low impact in the watershed. Very, very not very productive fishery. There's some artisan fisheries up there. Very good smoked fish. If you have the opportunity to stop by Russ Kendall's, but not a very productive fishery. Very, very productive when it comes to shipping. The Duluth is the largest freshwater port in the world. 66 million tons of shipping per year. Those numbers are a little bit old, but you get the point. $250 million a year in tourism. Low agricultural pressure, although that is slowly changing. There are more of these automated feedlots and stuff like that showing up on the Wisconsin side of that, and that's something that obviously lots of us are paying attention to. 100 megawatts power generation, which is not a lot, not for about 100,000 homes. This is from the state of the Great Lakes.
Where
Oh, go ahead.
power generation's coming from? Is there a waterfall into the lake or something?
My guess is that there are small dams.
Yeah.
So there's a dam, Thompson Dam, I think, on the St. Louis River, near us, which is very small, generates a little bit of power. There's at the Sioux,
Yeah.
they generate power there, and I'm guessing that most of that 100 megawatts is generated in Sault Ste. Marie. Good question. I should look that up sometime. It's not what I do. This is from the State of the Great Lakes report. I've been the lead author for temperature on this report for about 10 years. This is a joint product of the EPA and ECCC, the Canadian equivalent of the EPA. And this comes out every 3 years. And so we've gone through a couple. I couldn't find this nice graphic in the 2022 or 2025, but this was a very hand-wavy attempt to sort of give people an idea of roughly where these lakes stand. And most of them are not changing or getting worse or getting better, really. But Superior is the one lake, again, because of the relatively low anthropogenic stress on it, that qualifies as having a good status, whatever that means. And Erie, perhaps unsurprisingly, with lots of agriculture within the watershed, is characterized as fair to poor. This is another attempt at sort of the same thing, looking at multiple stressors. And blue is good and red is bad. And so, again, a lot of this is very apples and oranges, and it's really hard to add these things together, but people make good faith attempts to understand where things are going well and where they're not.
What are you actually measuring here as far as
Again,
high?
The best thing to do would be to go to the paper.
Okay.
It's been ages since I've read that. And so it's things like nutrient impacts, warming, pollution, impact on ecosystems, stuff like that. On the other hand, some of the fastest expected warming is in Superior. And so here, the red and orange colors you see represent large negative trends in ice cover duration, where you see a lot of that red sort of in this range here on Superior. And then in the eastern part of Superior, relatively large trends in summer water temperatures, weaker trends in the western arm. A paper that was headed up by my boss, Catherine O'Reilly, 10 years ago now, 11 years ago, good gracious, did a global survey of lake warming rates. It's a complicated thing to do, mostly because there aren't a lot of really long time series of lake temperature. We're lucky in the Great Lakes to have some, but Superior is the sort of bright red dot in the middle of the black circle there, and is acknowledged as one of the faster warming lakes anywhere in the world. And most of this is from satellite data, because we can measure temperature reliably from satellites. For a handful of lakes like the Great Lakes, we do have 45 years of surface water temperature measurements. So we can actually do a sort of an in situ study of what's going on there. This is the power plant at Sault Ste. Marie. Most of the power that this generates goes to operating the Soo locks, to get boats in and out from Superior to Michigan Huron. One interesting thing about this is that some engineer once a day has written down the temperature of the water flowing through the dam since 1906.
Wow.
Not the same guy. But the point is we have over 100 years of data. And I just sort of want to make a comparison here. This is the Sault Ste. Marie water temperature over the last 100 years. This data is not online. You actually have to like bug an engineer in Sault Ste. Marie to get this data. And I admit that I've sort of fallen down on the job here. The red curve is just a smooth version. And you can see that there's about a 3-degree temperature rise. That's not by all means very steady. In fact, most of it seems to have occurred since 1980. This is very consistent with other long-term measurements of temperature. But 3 degrees Celsius or 6 degrees Fahrenheit is not trivial. right? Given the sort of the volume of this. The other thing that I find interesting, this right here, GIS stands for the Goddard Institute of Space Science. They have been doing compilations of globally average air temperatures for a very long time. And here, the amount of warming, again, you can see it really pick up in about 1980, but the total range is on the order of a degree Celsius or maybe 1.5 to 2 degrees Fahrenheit. And so Lake Superior really is sort of this concentration, being in the middle of a continent and being at a sort of mid to high latitude, ends up resulting in relatively.
And just for clarification, this is a 10-year average, is that
The
right?
red is probably 10 years average.
Yeah, I think with the
Because-
IPCC, says they want to keep one under 1.5
Yep.
P
Yep.
is a 10-year average.
Yep.
So the
We're-
1.0, actually, I think it's more like 1.2 now, is, looking back 10 years.
Yep.
Including, so from 2016 to 2026.
Yep.
So.
Yeah, I made this graph a couple of years ago
Yeah.
and I don't remember the details.
Yeah, this year, I think or in 2025, I think we hit 1.5.
Yeah, yeah. And so another thing I'll emphasize really quickly is I put this red curve on here to sort of draw out the trend. But what we're trying to study here is a relatively weak signal against a very large background of interannual variability. There's still a huge amount of variability from year to year. 2014 was the polar vortex year. I'm going to show some data from that later. I'm sure people remember that. It was just absolutely brutal. The lake responded in kind. But remember that when we talk about these trends, they are in the context of lots and lots of variability from year to year that exists naturally. That is just part of how the world works, whether we were here or not. And so here are ice cover from 4 different years. And I grabbed these graphics from the National Ice Center. I should probably make my own because the color scheme here is horrible. Red represents lots of ice and white represents not a lot of ice. So I apologize. I will redo my graphics someday. But what I want you to see is that we have years in Superior with basically no ice, and that's been true in a couple of years recently. But then 2014, the gray, I should point out, represents what's called fast ice. In other words, ice that is locked to the shore. And so you could walk to Wisconsin from my house, right? There was fast ice in that whole chunk of the Western Arm. And then again, of course, around Chequamegon Bay and the Apostles and stuff like that, anywhere that it's relatively shallow and protected, you end up with lots of ice. And even in a warm year like 2017, you can see that like Black Bay and Nipigon Bay and Whitefish Bay and the eastern end of Lake Superior, Chequamegon Bay, Bayfield, all formed ice, even in a relatively warm year. Here, I did just dig these out today. This is the last 2 years. We've had a pretty interesting ice year. And I should point out that all of these are from the 18th of February. That tends to be about the maximum. The sort of mid to late February tends to be the maximum for ice cover on the Superior. Last year, we had a lot of coastal ice. You can see it forming in shallow water near the coast. This year, we actually had appreciable ice. We actually almost had to delay getting our buoys out. I showed you the pictures of the buoys before, because we can't have the buoys out when there's ice on the lake. They're not hardened against that. And we don't want our expensive systems being run down when some big flow of ice comes through. But we had a huge wind event that pushed all the ice off to Ontario somewhere, and we were able to deploy. Okay. So just saw the time here, 7 o'clock. Doing well. This is a shift. This is from a PhD student of mine, Dan Tietze, now works for NOAA in Ann Arbor, Michigan. And the bottom panel, don't worry too much about the top panel. The bottom panel is the amount of ice averaged over each individual winter season. I don't like the way he did this. This is the average here, and so if the bars are facing up, they're above average years. If the bars are facing down, they're below average years. What really stands out to me, well, 2014 stands out, right? Just crazy high ice year. But really in 1998, there seems to have been this regime shift where suddenly we're seeing a lot more of these low ice years and a lot fewer of the high ice years. I'm gonna update this plot in just a second. If somebody had called me up and said, you have to give a talk, but you get one slide, this is the slide. This is just winter air temperature. This is from Dan's thesis as well. And then this is winter average ice cover, and I'm not gonna go into the details of how we compute it. And each individual dot is a different year. So a couple things stand out to me. First of all, the years where there are ice fit remarkably well. Air temperature is a extraordinarily effective predictor of how much ice you're going to form. Not rocket science, right? If it's cold, you form more ice. What does, and then of course, when you get to zero, it has to flatten out because you can't have negative ice. And so there's a sort of a hockey stick. 2014, first of all, you can see how amazingly anomalous that was. I had a postdoc who moved to Duluth from Miami in January of 2014, and every day I'd look in her office and like, hey, she's still here. But 2 years earlier was 2012, a very, very low ice, very warm winter. The other thing that really stands out to me about this is that these years here are years with a lot of ice, where people are going ice fishing and they're going to see the ice caves in Bayfield, and it's impacting the shipping season. And so there are all these sort of knock-off effects of that ice cover. These right here are years with basically no ice cover, where you'll get them in the bays and harbors and stuff like that, but not on the open lake. The difference in average winter air temperature is about 2 degrees Celsius, is driving that difference. And so one thing that I face a lot as someone who does some climate change communications like this is like, well, 2 degrees doesn't sound like a lot. It was 10 degrees warmer yesterday. It's gonna be 5 degrees warmer tomorrow. Why do I care about the fact that it's going to be 2 degrees warmer by the end of the century? The answer is there are systems like Lake Superior that are unbelievably sensitive to these very, very small changes. That fascinates me. I'm still getting my head around that. And in fact, you can extend this analysis to the other Great Lakes. You can ignore Ontario because it doesn't really form ice. Deeper lakes, you have to remove more heat from the water before you can start to form ice. So deeper lakes require colder temperatures. But the slopes of those lines, Superior, Michigan, Huron, Erie, the slopes are about the same. So that sensitivity, almost, yeah. And I'd be willing to bet if I put some error bars on this sort of thing, they would be indistinguishable from each other. So Erie very reliably forms ice because it's very shallow, even though it's in a relatively warm climate compared to us. Ontario is a warm climate, but deep, and so it forms very little ice. Those are the little blue ones down here. You can see a sort of sore thumb on each one of these plots. That's 2014 in each case.
This is linear data.
I'm not doing no log plots here. No,
Yeah.
that's cheating. Yeah. And so ice cover is a function of air temperature. This is the same plot that Dan produced, except I updated it to 2022. Trends remain the same. You see more green dots pre-1998 data here. You see more red dots post-1998. That average ice cover turns out to be a good predictor of average summer water temperatures. And so the less ice you have, the warmer you're at the following summer. This is the stuff that I'm currently in revisions on a paper showing that I was wrong in 2007, which is an interesting experience. But ice is still a decent predictor, even if it's not the main driving cause of variations in summer water temperature. Here is, I think the only one I care about is the top panel. This is the difference between the beginning and the middle of the century. This is from NCA3. And you can see up in the Superior region, we're talking about 4 or 5 degrees warmer by the middle of the century for average temperatures.
This is projecting to 2050 is what you're saying.
Yes.
Okay.
Yep.
Given the trend.
I don't remember what the baseline for this is. It's probably like 1980s and 2000 or something like that. That's a pretty standard one. Anyway, this is from my colleague Bob Sterner, former director of LLO. The higher up the curve is, the warmer the summer is. And the red and the blue curves represent years where we have observed algal blooms. And so a reasonable hypothesis is that warmer waters are more hospitable to these algae. So far, these are what are called nuisance algae. They're not toxic. I would not want my dog drinking this water. But so far, they've been nuisance algae, but that says nothing about what's going to happen in the future. We tend to associate algae blooms with Lake Erie, because it's shallow and very, very warm and has tons of nutrients being pushed in off of farm fields. The fact that we're suddenly seeing this in, pristine Lake Superior, is raising a lot of eyebrows.
You say suddenly seeing it, I mean, historically, like before.
So this is a really hard thing to nail down because there's an observational bias here. Was somebody there on that day? Right, but we're getting a little better about making these observations a little more systematically. And what we are seeing are these high algae years in years where we're measuring warmer water temperatures. Water levels are changing. So we had storms in 2018 and 2019. The lake was a little bit deeper than normal, which has an outsized effect on how much damage a storm can do. And so here, 18 million in damage in 2018. You can see pictures of my beloved lake walk getting torn up. And of course, high water levels, even in the absence of a storm, pose a real threat because we have this built infrastructure around the Great Lakes that assumes that the water level never changes by more than about this much. Coastal oceans, tides are like this, right? But they build for that understanding that there's going to be this huge variability on a 12-hour basis. We didn't do that. We just said the lakes are always going to be right here. Let's build our docks where they are. And of course, it's not just high water levels, but low water levels as well, that pose a threat to ecology, but also sort of recreation and commerce. Here's a list of historic mega rain events from the Minnesota DNR. Out of 16 events, 9 of them have occurred since 2002. 1, 2, 3, 4, 5 of them have occurred since 2010. I was around for this one. Duluth was dead center for this storm. Lake Superior got 4 inches deeper in 24 hours. Not just the west, when the rising tide raises all boats. When the water goes up in here, it goes up across the entire lake. So imagine taking Lake Superior and adding 4 inches of water. That happened in 24 hours. This is a fun, I want to wrap up pretty soon. Forrest Hauk was a high school student down in Bayfield. And he went and looked up newspaper reports of when the ferry stopped running in the winter and started running the following spring.
This was in the Star Tribune years ago.
Undoubtedly, yeah, it was a very clever paper. And you can see that the timing of the last boat has gotten later and later. The timing of the first boat the following season has gotten earlier and earlier. I'd love to get my hands on this data set and compare it to some other sets.
That was the Madeline Island ferry?
The Madeline Island ferry, yes. Yep. These are from lakes around the world. This is John Magnuson, who's emeritus down at Madison. And in general, you can see ice breakup dates getting later. Getting earlier. This is inverted scale, and ice formation dates getting later. But I think the thing that really I find intriguing about this is the x-axis on these. Data in Lake Suwa in Japan has been recorded since 1450. Right? That tells you something about this is culturally or even spiritually important to these are Shinto priests, unsurprisingly, collecting this data and recording it faithfully for the last 600 years.
Benny's Barbershop here in White Bear has ice out every year for the last 100 years, I think.
I would love to see that. This is from a procession called the Siegfriede, Lake Constance, bordering Austria, Switzerland, and Germany. Every time the lake freezes over reliably, this icon of the Virgin Mary is carried across the lake from a church in Munsterlingen to a church in Hagnau. And this doesn't, there's not really a climate signal here, but what it does, first of all, this is the number of freeze events for each century back to 875. So there's almost 1,200 years of data. And what you can see in this is a little ice age, right? We certainly had lots and lots of freezes compared to nothing in the last 50 years. Maybe not a surprise. Back to Japan for a second. The Omiwatari, which means God's crossing or where the gods walk, represents this ice ridge that forms across Lake Suwa. There's Lake Suwa again, representing the god's footprints as he walks across to find his lover. Sorry. And then the number of years without an Omiwatari is the graph. So it's a little bit backwards, but what you can see is that most centuries have half a dozen or something like that. Since 1919, they've missed it 25 times. That is a climate signal. So, not that ice isn't culturally and spiritually important to us here in America. People park cars on the ice, and you put in your ticket at the pub. That's when these things are going to fall through. And again, my point here, I don't have data on this, but the point here is again how culturally important lake ice is to people. And then of course, ice fishing tourney cancellations in central Minnesota are, so unsurprisingly again, a function of the winter air temperature. This is again from this paper by Leslie Hill. And so you have warmer air, you have less ice or less safe ice, and they have to cancel. So there are these sort of knock-on effects of losing ice in these systems. So concluding remarks. Long-term records are essential for putting current conditions into context. We need to understand what the long-term trends are. It's hard to learn anything from a couple years of data. And so we need to understand what happened in the past. There's strong seasonal connections. I did downplay this a bit in here, but winter is really important for understanding what happens the following summer. And so as we lose ice, as these lakes are warmer, we end up with longer summers, longer periods of biological productivity, and warmer summer water temperatures in general. There's been a strong decrease in ice cover, at least in Superior and other Great Lakes, in the last 4 decades. And finally, I think I've made the point that ice cover has a strong cultural resonance that I think is important and worth paying attention to. So, okay, with that, thanks so much. I'm happy to, picture's taken a while ago. Happy to entertain questions.
You mentioned one of your early slides about albedo effect. Do you look at how, any correlation between, the temperatures and how much ice is on there, given your albedo effect is how much sun is reflected.
Yep.
By.
Yep. And so Steve and I wrote this paper in the bottom right. This is my by far my best reference or best cited paper.
Oh,
It's been cited about 700 times. And we showed that ice cover was a good predictor of water temperature the following summer. And we hypothesized that this was because sunlight was bounced off of the ice and didn't go into heating the water. Turns out we were wrong. That's fine. We understand that it's really what's going on below the ice in the water below. And it's been an interesting exercise for me as I've written up this paper, bashing down this very, very well-cited paper from a while ago. So I don't make a lot of direct measurements of things like albedo. Having stuff out there in the winter is understandable. At surface especially is particularly difficult. Go ahead.
So unfortunately, you mentioned that one organization in the papers now or the report is no longer.
Yeah.
Are there still guessing the same group of people coming together, maybe since you're all volunteers, producing this data?
Yeah, so the question was, with the National Climate Assessment being defunded by the federal government, is there like a grassroots effort to continue that good work? I don't know. I will say that doing that report was a very interesting experience and one I have no intention of repeating. It was difficult for me as a non-climate professional. They have very, very specific vocabulary that they use, and they argue over adaptability versus, I don't remember all the words, but I was a little bit fish out of water. So my guess is if there is something like that, they're probably not going to call me again. But I think that the trick is that it's not just, there's a huge amount of volunteer. This is the author list for chapter 24, right? There are a lot of us on this, right? We had one meeting in person in DC. Everything else was done on Zoom. But there are people that are coordinating all that. And so you actually have to have some sort of organizational structure. I think it would be hard to coordinate something at this scale, unless some big foundation stepped in or something like that. The trick, of course, then is people start to question the motives of a foundation that steps in to do stuff like that. The IPCC will continue, International Panel on Climate Change will continue to provide reports. The State of the Great Lakes report will continue. Fortunately, the EPA hasn't seen it necessary so far to shut that one down. But no, I don't know. It's an interesting question.
Has your research been, your funding been in danger because of the new administration?
I continue to have a relatively good funding record. I will say that I'm not as enthusiastic about submitting the next proposal, just watching everything happen the way they are, and also sort of being close enough to the end of my career that it's like, oh, you know what? I just don't need the trouble. But yeah, lots of my friends at the EPA lab, in Duluth has a big environmental protection agency lab, and a lot of them just got laid off, right? And so there are direct effects of what's going on at the federal level. This report disappeared from EPA's website for a long time. It's recently been reposted at climate.epa.gov. But one thing that worries me is sort of the end of some of these long-term time series that we've collected. I've demonstrated here that in order to understand these phenomena, we need to be doing things over decadal scales. And if you suddenly have a gap, it just makes it that much harder to understand what's going on. But no, my funding is in place. I'm not going to go into the details, but yeah, we have funding. So the buoys went out this year, courtesy of Minnesota Sea Grant. We had a big deployment last year called the Lake Superior Ecological Observatory that was funded by the Great Lakes Observing System. Got a couple, actually I'm not going to go into that. I think what really kills us right now in the field is just the uncertainty.
Yeah.
Yeah, that's the hard part to do.
You had a chart that showed lake temperature versus time, and I couldn't read the x-axis for time. Early on in your slides.
That there?
No, that one,
I'm not sure. I'm not sure which one you're talking about.
Yeah,
What was your question though?
You could.
I just want to look at the
Oh,
how much time with the decades.
Yeah.
Years.
and so sort of the numbers in my head are that we have reasonably reliable ice cover data back to about 1973. We have summer surface water temperature or spring, summer, fall surface water temperature since about 1980. And we have full water column temperature data in Michigan since about 1996, and in Superior, that's my lab, since about 2005. Those are the big long time series. A group at the Great Lakes Environmental Research Lab recently did a really cool data synthesis project where they came up with daily sub-basin-wide air temperatures for each of the Great Lakes back to 1897. And that's from like airport data and National Weather Service and what have you. It's a complicated thing to come up with a single number. But what that paper has allowed me and some of my colleagues to do is I was about to say predictions, but make inferences about what happened in the past. And one thing we're seeing, I don't have any slides on this here because it's a real rat's nest, is that lakes are characterized by how they form what we call stratification, whether you have warm water on top and cold water below, and how that stratification develops over the course of a year. One thing we're seeing is sort of maybe the limnologists, study for people who study lakes, they like to put these labels on. This lake is a dimictic lake. This lake is a monomictic lake. I'm not going to go into what those words mean. What we're seeing is as things are warming up, they're shifting from one regime to the next warmest regime. Those stratification cycles are really important for the ecology of these lakes. And so one thing that I am starting to pay more attention to is what does it mean that this lake is no longer forming winter stratification, right? What does it mean that it's not cooling down below X level? Those sorts of things. And so trying to remember where this was coming from, but Yeah, oh, the long time series. And yeah, so now we can actually make estimates of how these lakes were behaving back to the late 19th century, which I think is pretty cool.
So
And that we see them changing.
you mentioned stratification. You're talking about
Yeah.
when the temperature inversion and you get the turnover on the lake.
Oh, don't get me started. So I am the authority on how lakes make that transition right now. And so the quick story is that in the summer, you get warm water sitting on top of cold water. We're all familiar with that because we put hot air in hot air balloons and the hot air rises. Or you go into your house on a warm summer day, it's warm upstairs and it's cool in the basement. That's because hot air is less dense and it wants to rise. In the winter, the opposite is true. Cold water wants to sit on top of slightly warmer water below, which takes a while to get your head around. But again, trying to remember where I was going with this. Yes, stratification one thing that I'm very interested in, and half of those papers you saw me put up titles for, is when lakes either stop being stratified and go into some sort of transition, or start being stratified again and either become winter stratified or summer stratified. And the processes that mediate that are really very complicated.
What's your take on the zombie trout?
I don't
There was
know.
an article in Star Trib about the.
Yeah, just today in zombie trout, right? They're pulling trout out of the deep waters of Lake Superior that were just emaciated, just starving. You hadn't heard of that?
No, I haven't. I'll do a quick search and learn what I can. But it's not been a particularly anomalous year, so I'm not sure why that would be going on right now. I mean, to me, the bigger fisheries story will always be invasives, right? And so one thing we do as we make these lakes warmer is we make them less hospitable for the species that evolved there. Ultimately everything is invasive. But things that have been there for thousands of years versus something that got dumped out of some boat that was just in the Black Sea or something like that. So far, Superior has been safe from things like zebra and quagga mussels. The lower lakes have been completely replumbed. They have completely different ecosystems now than they did even 20 years ago because of these rapid invasions of dracinid mussels. Again, not a biologist, but I have some vague sense of what's going on there. Superior is too cold. It also doesn't have the right elemental makeup to form the zebra mussel shells.
Around Isle Royale,
Yep.
how often does the lake freeze over so that animals can cross over? Does that vary or is it pretty consistent?
I would assume so. And so I can't speak to that one little thing there, or that one little area. There's certainly data out there. So you can go right now if you wanted to and download 2-kilometer gridded ice cover on a daily basis back through 1973 or something like that.
Oh,
And so
okay.
you could draw a little circle around the little area between Canada and Isle Royale and figure out which years it froze and which years it didn't. The thing I will come back to though is, here, look at the number of bars above the line before 1998 and look at the number of bars that have the line after 1999. And so what that will do to, I don't know, wolf populations, deer, moose. There are people, well, I guess mostly at Michigan Tech, I think, that study the population dynamics up there. That's a really interesting question. And the other thing I'd like to do is talk with some phenologists about phenology is the study of seasonality, and to see if when the lilacs bloom are a function of what the lake is doing. I know Duluth is still really cold. I was out on the lake last week and the water temperature was 34. So just moved beyond freezing. But it's genuinely chilly up there. This is actually quite nice. So, but my point is that lake water temperatures play a very important role in our sort of regional climate system. So,
You mentioned lake level variability with
Yes.
Superior. For such a large lake, it varies significantly. Is there a trend there? Is it going up? Is it going down? Is there any trend?
I think that, what's the saying? The new normal is that there's no new normal. For a while in 2018, 2019, they were getting these really high stands of water. Duluth got the stuffing kicked out of it in some November storms. You know, the thing is, if the water level goes up by this, it goes this much further inland, right? And then sometimes that's enough to overtop seawalls and stuff like that. But when I started here, we had lots of I don't have a water level graph with me. I could certainly stuff you could look up. But yes, we've had these very low stands and very high stands of water, and our infrastructure is not well adapted to either one of those, I think is the real trick. And so I couldn't tell you, I don't keep track of anything on a daily basis, otherwise I'd never get anything done. But I couldn't tell you where the lakes stand right now.
There was a rock, the Gooseberry Falls, on the coast, not at the falls, but out right on Lake Superior. And I climbed up on that rock and somebody took my picture on that rock. Must have been 10 or 15 years ago.
Mhm.
And I've never been able to get that rock since because the water is so much higher. Every year we go up there, I can't get on that rock.
Yeah, again, it would be worthwhile me
It's interesting.
paying a little more.
Difference in water level in the lake.
Yeah, and I think the point here is that if you look at a normal year in Lake Superior, lake is typically high in the early summer because you've had the big spring freshets of all the snow melting and pouring into the lake. Lake level goes up, and then through the winter, as you have evaporation off the surface of the lake, evaporation occurs mostly when very cold air blows over the surface. You get the low stand in like, I don't know, January, February, something like that. And the difference is typically 50 centimeters, 70 centimeters, not very much. And so when the lake is suddenly 50 centimeters deeper all year round, it makes a real difference.
There's a huge gravel beach on Chattagooch. Ever been to Chattagooch?
Yep,
Okay.
of course.
Big gravel beach. And I've got pictures 3 years in a row. 1 year, big gravel beach. The next year, it was gone.
Yeah, yeah.
The year after that, it's all back.
Beaches are funny.
Huge, tons and tons of gravel.
Yeah, yeah.
What is going on there? Yeah, I went to the ranger to talk to him about it.
The lake is
the winter storms can bring the rock back up.
Yep. The lake is very, very powerful.
Very
And it's not to be messed with. And yes, it can move around hundreds of tons of gravel if it decides to. Yes.
yeah.
So.
Okay, right, any other questions for Dr. Austin? All right, let's
Okay.
give him a hand.
Thank you very much.
Everybody online, we'll be shutting down now. Is there an opportunity?